Hello.
Hello.
Sorry. Hello. Hello, Edric. Hello, Edric. Basically, I like for a second, I thought that a small kid. Zoe is front of me. That's why I said hello like that.
Oh,
Okay. So, good morning, Edric. How are you?
I am so good. I am feeling so happy to be with you, sir.
Yeah, you're happy.
Yes, sir, I am.
Very good. So it's very good that you're doing homework also. And that's a necessary change which I saw in you.
Sir,
Before you used to do the homework, but now you are saying, sir, I can do the homework. Like,
but you know what? In 10th class, when last minute I created a mess because of homework in 10th.
yeah, yes, yes, correct. Okay, so today we gonna learn. So we did isobars and
Yeah,
isotopes, yes?
isotopes are and isobars are.
Okay, so now today what we're going to do today, and we did the Rutherford also. Okay,
Yeah,
now we'll learn about the electromagnetic radiation.
yes, sir.
Electromagnetic radiation. Why electromagnetic radiation? Because this thing leads to the this thing Niels Bohr theory. Okay, it
Sir,
supports the Niels Bohr theory. Yes,
you know the Z-man effect and the Stark effect?
yes, it will come in this.
Yeah, come on that.
Okay, so we have electromagnetic radiation. Okay, so what is electromagnetic radiation? So basically, Niels Bohr did one, and he clarify or he correct Rutherford theory. Okay, based on two concepts. Based on two concepts. The first concept is that every electromagnetic radiation, okay, electromagnetic wave, has dual part nature. Okay, so means electromagnetic means any particle that is moving, it has dual nature. Okay, so for example, if this particle, this is a small particle, if it is moving, so it has dual nature. Dual nature. The first one is particle nature.
And
First one is particle nature,
second
and
one is
second one is
wave nature.
wave nature. Correct. So we have particle nature as well as wave nature. So first concept is this, that particle, if it is moving, like any charge particle, we can say any charge particle, if it is moving or accelerating, then we have two types of nature. First is two natures are there. First is particle nature. Particle nature means the movement, mass, momentum. These are things. The particle nature. And wave nature is the I'll will discuss about the wave nature, in which we will see that there is some radiation. The waves are coming out from that particle if it is moving, charge particle. Okay,
Yes.
did you understand?
Yes, sir.
So, and the second one is second concept which he used. This is the first concept. Okay, when the second concept he used is he did some experiment result of atomic spectra. Now, what is atomic spectra? It's basically called as atomic spectrum. So we are going to learn in the coming part.
Yes, sir.
Did you understand?
Yes, sir.
So first we will understand what is the meaning of this um, wave nature. Wave nature. So, can you will you write this? Will you write this?
Okay, sir.
Done.
I'm sharpening the pencils.
Sorry.
I'm sharpening the pencils, sir.
Uh, done.
Almost. Done, sir.
Okay. So now we are going to learn wave nature of electromagnetic radiation. Okay. Now, what is a wave nature? So basically, what this thing says that when a charge particle, okay, when a charge particle, no matter it is positive or negative, when a charge particle is moving, okay, then alternating electric and magnetic field are generated and transmitted. Means if a charge particle is moving, then it has the particle nature, which is the movement, momentum, speed, velocity, like this. And what is the wave nature? That alternatingly the electric current and magnetic field is also coming in the form of wave. So those waves which are coming when a charge particle is moving, that waves are called as electromagnetic radiation. So electromagnetic is made up of two words, electricity and magnetic field. So
Yes.
when a charge particle move, it will generate two waves, electro as well as magnetic.
Yes. Yes, sir.
Okay. And these waves are 90 degree to each other. Okay, these waves are 90 degree to each other. So if I will show you the diagram from your book, so it's gonna be look like this. See, so if the charge particle is moving in this direction, and we can see this is the electric field, okay, and this one is magnetic field, which I will make it another way. This one is magnetic field.
Yes, sir.
So they both are coming in 90 degree. Remember this thing. This is 90 degree. The electric field and the magnetic field, they will propagate in 90 degree. Did you
They're
understand?
perpendicular. They're perpendicular.
Perpendicular. They're perpendicular. Okay, will you write? I'll dictate.
Yes, sir.
Yeah. When electrically charged particles, when electrically charged particles
Yes, sir.
move or accelerate,
Yes.
help in no, what I say? Move or
Move or
accelerate,
accelerate.
accelerate, alternating electric current and magnetic field are generated automatically. Electric current and magnetic field are generated and transmitted in the form of waves. These waves are called as electromagnetic waves. These waves are called as electromagnetic waves. Now we'll learn about the wavelength.
Sir,
Yes.
tomorrow I have an Allen test. An Allen test.
o-
Yes.
Okay.
Like in the coaching class, Alan, I have a test tomorrow because it's a Wednesday, and every 3 Wednesdays I have a test. Once in 21
Oh.
days.
Okay, okay, okay.
I have a test once in 21
So
days.
today then I'll not give any. Okay.
Okay.
You enjoy with your test. Again. No problem. So now first we'll understand what is this. So I need. Now I am, for example, I am taking this electromagnetic waves, and in electromagnetic waves, basically this thing,
Yes, sir.
electric field waves. Okay, so basically we learn that these are the waves from. So now we will learn something in this, and that is called as the topic will be characteristics of the wave. We put a thing. This one is first, and the topic is characteristics of wave. So first is we will learn one oscillation. So what is the meaning of oscillation? Tell me, Edric. What is oscillation?
So oscillation means like it will go up, down, up, down, up, down, up, down.
Yeah, but if I will say what is the meaning of one oscillation? One oscillation is the oscillation in which listen, in which one. So basically, this upper part is called as crest, and the below part is called as trough. This one is also crest, and this one is also true. Now listen everyone. Now we have to understand this, then I'll give you time to write. Listen. So first is one oscillation. One oscillation means when one crest and when one trough comes, it creates one oscillation. This
Yeah.
is called as one oscillation. Got it?
Yes. That means from the zero it will move to the crest, then again zero, then the trough, and then again back to the zero.
Uh, so this is called as one oscillation. We
Yes.
can do one more thing. Like I can start from the top of the crest, then pull trough, then pull this
Crest.
thing. Yes. So what I did, I basically here I shifted little up. So this part is also shifted to this part.
Yes. That means it's still
Okay.
one oscillation only.
It's only one oscillation.
It's not one and
Yeah,
a quarter oscillation or one and a half oscillation. There's one
yeah.
oscillation.
It is one oscillation. We can do like this also. Like I start from the middle of the throw, then I took one whole crest, and then again like this. So basically, it was from this point. Now it came to this point. So obviously, this point also came to this. Got it?
Yeah.
No. So oscillation. I'll give you the definition, but oscillation definition no need. Okay. Now second one is wavelength. Now what is wavelength? So wavelength is the distance between two crests or throw. So two crest and throw means if I will take this crest and if I will take this throw, the distance between them is called as wavelength.
So between one crest and one crest is wavelength. Between one trough and one trough is wavelength. Between one zero and the next two zeros also a wave.
Yeah. So this zero and this zero.
Yes, sir.
Okay.
Yeah.
So we can write that like this that the distance between I'm writing this the distance between two crests and two throw are called wavelength. And it is represented by this. This is called as lambda. Like I used to make it like this. I'm
I
very
write
bad at
it like
this.
I write it like
Like
this.
I like I used to make it like this, when we are doing the calculation. But okay, it's okay. Did you understand? So it means that if I will take this point, if I will take this point to this point, okay, so that distance is called as lambda.
Wavelength. Lambda.
Okay,
Mm.
got it? Now second one is frequency. Second one is frequency. Now, for defining the frequency, we used to make it like this. Call this mu. Okay. Now, frequency, I will explain in this thing. Now, for example, in 1 second, I am taking 1 second as a reference. In 1 second, here, how many waves are formed? We'll check. Two, three, and four.
Sir, so why are you making diagonal? Like it's a bit slanted. Like like since it's slanted, like the time will you're basically time traveling.
You want me to make 90 degrees?
I mean, no.
Then?
Yeah, like this. Yeah, like this.
Hmm.
Yeah, this is correct. Because here it's not slanted. Here it's like this. Not like
Yeah,
this. Like
yeah,
because it goes like this, you're basically time traveling.
yeah. So basically, now we have this part. Okay, in 1 second we have how many oscillation is formed? This one is one and two and two and a half. Okay, two and a half oscillation is formed in 1 second. Okay, and for example, we have another wave like this, and in this 1 second, it forms this. This is 1 second. So in 1 second, only one oscillation is formed. One oscillation in 1 second. Now, what is the meaning? Uh,
Okay, so frequency is the number of waves in 1 second. Number of oscillations in 1 second.
Edric, you were saying something on call?
Okay, so basically frequency is the
I can't hear
number
you.
number of oscillations in 1 second.
Yeah. So we got this that here in 1 second we are getting two and a half oscillation. In this we are getting only one oscillation in 1 second. So it has the frequency less. Okay, and it has the frequency more. Okay, and if more frequency means more pitch. We are not going in that pitch part, which is sound related. But what I'm trying to say in this is the number of oscillation in 1 second. Number of oscillation in 1 second. Okay, did you understand? No. Okay. Now, so one, if I will write its unit is hertz. So 1 hertz means one cycle per second. Okay. Another thing, Edric, the wavelength unit is in meter because it's a length. No? That is right. Now, now we'll talk about the time period. Time period. So time period, which is denoted by capital T. Now it means that one oscillation is done by how many seconds? Are you with me? Hmm? Like in 1 sec, like not in 1 second. Like one oscillation takes how many time? How much time?
Yeah, one oscillation means okay. But frequency is in 1 second, how many oscillations? Here, in one
Uh,
oscillation, how many seconds?
how many seconds? For example, we'll take this example. Now this example shows that one oscillation in 1 second. And this example shows that two and a half oscillation in 1 second. So if I will divide, so it will become 0.4. Yes?
Yes.
So it means that one oscillation takes, in this case, is how many? 0.4 second. That is the time period.
Yes.
And this 1 second.
Yes, sir.
So because the time period is less, then frequency is more. So we got one thing. So I'll write the definition of this. What is time period? Time period is one oscillation, or you can say time taken by one oscillation. Time taken by one oscillation. Now from this, what we got? From this we got time taken by one oscillation means time period is equal is indirectly proportional. We can say frequency is indirectly proportional to 1 upon 2. Like for example, in this, it is 0.4 second by one oscillation,
Yes. Yes.
and it is 1 second in one oscillation. So time period is less, and that is why the frequency is more.
Yes, sir.
Okay, so we got one formula that frequency is equals to 1 upon time period, and the time period should be in second.
And frequency should be in hertz, right?
Yeah, if time period is in second, then we'll get the frequency in second. Or in some books, in some questions, to find it out that is it frequency or what. Okay, so hertz is the main thing. Like for example, if in a question 20 hertz is written, so 20 hertz is frequency. But for like in examination, they sometimes use as second minus one, second inverse,
Yeah, for hertz, they sometimes use a second inverse.
second inverse. So that second inverse is basically the time period.
Yes, sir.
Okay. So now fourth term. The fourth term is
Fifth term, fifth term, fifth term.
one. No, fourth. No.
Wait.
Oh yeah. So this one is fourth.
Yes.
This one is fifth. The fifth term is velocity. Velocity, which is denoted by c. Now it will become c. Okay.
So why
So
not
what
V?
is velocity?
So why
What?
not V? Why not V?
Like we use frequency for that. No,
That
it's not a v. It's not a v, but in some books it is known as c because speed of light we consider it as a c. So speed and velocity we take it as c. So that is also one of the reasons. But like if you, it's your about you. Okay. Now listen. So velocity. Velocity is basically wavelength in time period. Did you understand?
yes, sir.
Okay. So c can be written as lambda into t. The speed of the wave, no?
So it
Yeah.
is it
Ah,
that's nu
lambda
into
upon
lambda.
t.
Nu into lambda. Nu into lambda.
Yeah.
Nu.
And from this we got one more diagram that c is equals to lambda into mu. I'm making it wrong. Okay, so these two formulas are important. And now we'll talk about what is a wave number.
Sir, sixth quantity, sir. Sixth quantity, not
Six quantity is wave number. Now, wave number is basically written as lambda dash. Okay. Either lambda dash or we can write it like this.
mu bar.
Mm,
Mu bar.
mu bar. Mu bar also some books is written.
Lambda bar or
Mu bar.
nu bar. So not
Mu
dash
bar.
bar because it is above it. So it's bar.
Yeah.
The line above. So it's bar, not dash. Not
Yeah, bar. Okay.
bar.
Okay. So now what is wave number? Wave number is basically it is defined as the number of waves, the number of waves per unit length. So there's a difference between the wave number and wave length. Wavelength is one wave, how much length? Okay. And wave number is 1 meter length, how many waves? Did you understand
Sir.
the relation? Wavelength means uh, in 1 meter. No, wavelength is a wave has how much length? Okay, you can ask from your like whenever you're solving, you can understand it like this. Wavelength means a wave has how much length? Wave number is a 1 meter length has how many waves?
Yes.
Okay, so we got one relation that wavelength is equals to 1 upon mu lambda. So right now we learn the four formulas. The first one is frequency, which is 1 upon time period. Then speed, velocity is equals to lambda upon t. Frequency is equals to lambda into mu. And this one is also there. Lambda is equals to 1 upon wavelength. We can make one more formula. Can we?
Yes,
Can we
sir.
make one more formula? What?
Nu bar is equal to 1 upon of lambda.
Yes, it's correct. But we can make one more formula, which is C is equals to frequency upon wave number. Did you understand? Velocity is equals to frequency upon wave number, not wave length. Eric didn't understand anything?
Frequency upon of wave number.
Wave length. Shall we do one question now?
Okay, sir.
Okay. So now the question, you wrote everything, no?
Yes, sir. Everything, sir.
Okay. So the I'll do this. Okay. This is the question. Okay. So Edric, we will do this? The first is angstrom is there. It's not in meter, so we have to convert them into a meter. So how will you make it?
Wait. Wait, with angstrom also we can do. Wait, yeah, yeah. The frequency is equal to velocity upon wavelength. So wavelength, so frequency will become 3 into 10 to the power 8 meter per second upon of 5,000
Why? See,
5,800
listen. It is
into.
written as yellow radiation light, no?
Yes.
That is why we have to take like yellow radiation light means the speed of light, which is in visible rays. We are going to learn in the coming classes. There are some ranges like UV rays, infrared rays, ultra infrared rays, microwaves. So these their speed is different from the visible range light, which is the yellow light. Okay, so we'll take the speed of light is 3 into 10 to the power 8 meter per second because it is the speed of light in visible. Did you understand?
Yes, sir.
Okay, yeah. Next, tell me.
So now we can take the wavelength as 5,800 into 10 to the power minus 10 meter.
5,800 into 10 to the power
Minus 10 meter.
minus 10. Very good. Okay. So now we have to calculate first wave number. So wave number is reciprocal of wavelength means 1 upon 5,800 into 10 to the power minus 10. So if I will calculate a wave number, okay, so it will be 1 upon 5,800 and the 10 to the power minus 10 will become 10 to the power 10 and 1 upon 5,800 is 1.724. 1.724 into 10 to the power 6 uh, meter inverse. So wave number unit is meter inverse. Calculate. Understood?
Yes, sir. Yes, sir. Understood.
Okay. And now you have to calculate the velocity. Quickly solve this and tell me. No,
Frequency, sir. Frequency.
frequency.
Frequency is equal to velocity upon wavelength.
Yes. Or we can say frequency is equals to velocity into wave number also. You can say this thing also. You can use this one also. So frequency velocity is 3 into 10 power 8, and then you will multiply with this, you will get the answer. Did you understand? No.
Wait. Yes.
So this calculation will be easy, I guess. 8 quarter 12, 1 will come, 1 will become 7, and 3, 7 are 21, 1, and then 2, 5.172, correct, into 10 to the power 14, and hertz I will write, or you can write second inverse. Did you understand? No.
Yes, sir. Done.
So, uh, so this is what we learn today, in which we learn about the wave number, all these important characteristics. Let me see if anyone is left. I guess we did this. And tomorrow we'll do this part also. The after 2.2, because we got one formula. Electromagnetic also show characteristics of particle. This is called as quanta. Quanta are actually the bundles of energy, like how much energy is there. Okay, a quanta of a visible light is called as photon, photon. And the energy of quanta is proportional to the frequency of the radiation. So more frequency means more energy is there. That is why the girl is like, that they will break the glass, no? So because they are making high pitch means more frequency means more energy, and able to break the glass.
Yes, sir.
Got it? So
Okay.
we are going to learn that quanta part again. So remind me, sir, on Thursday 53 after 2.2. If you will take page number 53 after 2.2, you have to teach. Okay, please remind me.
Yes.
You make a line on that. Okay, after 2.2, you teach me. Okay, so
Yes.
we'll learn about the quanta. Okay, so we'll end this class. Eric, did you enjoy the class?
Yes, sir.
Make yawning with a big mouth. I guess you didn't enjoy.
Enjoyed, sir.
Fine.
I enjoyed, sir. I enjoyed, sir.
Yeah, perfect. So I hope you have enjoyed the class. Till then, bye. Have a nice day. We'll meet on Thursday. All the best for the test. Bye.
Okay, sir. Thank you, sir.
Bye.
Bye,
Thank
sir.
you. Bye. Guys, 10 class. Good morning. Give me 2 minutes. We'll start the class. Hello, guys. Good